we can change a fraction to a decimal by treating it as a division sum. So let's do that with example A. We have 2 over 5, which you can treat as 2 divided by 5. Now, using long division, first step, if we ignore remainders, if they exist, is to carry out 2 divided by 5, which is simply 0, with us ignoring remainders. So using long division, we have our next step, which is to multiply 5 by the result we found, which was 0. This gives us 0, and then this is subtracted below. From the 2 minus 0 means that 2 remains. Now, 2 over 5 as a decimal clearly isn't 0, and as we have a remainder down here of 2, we're not finished with division either. So this is where the decimal point comes in. We currently have no more digits in the dividend to bring down, but the decimal point will enable us to. Placing a decimal point on the right of the number 2 will allow us to write as many zeros as we wish on the right of the decimal point, which will thus give us more digits that we can bring down to do some further division. So we can write 3 zeros. We may not need them all, but we can write them anyway. And the reason we can do this is because the number 2 on its own is the same value as 2 with a decimal point to the right, and any number of zeros afterward. Doesn't matter how many, we have the same value. So we're still dealing with 2 divided by 5. But we do need to remember to also place a decimal point above, where we have our answer in the same place. And that makes sense because we are looking to change a fraction to a decimal. So, let's bring down the first 0 after the decimal point alongside the 2. That gives us 20. So now we carry out 20 divided by 5. And that gives us 4. So like before, another step, which is 5 multiplied by this 4, subtracted below. 5 times 4 gives us 20. 20 minus 20 gives us 0. And in fact signals that we have completed the division sum that we set up of 2 divided by 5, which gives us the decimal form of 2 over 5, the fraction. So 0.4 is the decimal form of the fraction 2 over 5. Using long division, we have successfully converted 2 over 5 to decimal form. For example B, we can look to convert 17 over 8 to a decimal. So we again set up as a division sum, but we can place the necessary decimal points at the beginning, along with the extra zeros, as we know we'll need them, or some of them possibly, to bring down as we do our division. So if we start off, we have 1 divided by 8, ignore any remainders, this is 0, then 8 multiplied by 0 is also 0, so we're left with the 1. Now we can bring the 7 down, and this will be divided by 8. So ignoring remainders, it gives us 2. Then 8 multiplied by 2, 16. So if we subtract 16 below from the 17, we're left with 1. So, as the result is 1, a non-zero, that means there's more division to be done. So we can bring down the first 0 that we've put on the right of the decimal point, bring that alongside the 1, gives us 10. So we can carry out our next division, which is 10 divided by 8. Now ignoring remainders, this is 1. Then we look at 8 multiplied by 1, and this is subtracted from the 10 to give us 2. 2 is non-zero as a remainder, so more division to be done. Another 0 we can bring down, just fine. Alongside the 2, this gives us 20. So, ignoring remainders, 20 divided by 8 gives us 2, which goes up in the answer. Then, 8 multiplied by 2 is 16. This, subtracted from 20, leaves us with a result of 4. So we'll bring one more 0 down. It looks to be, gives us 40. So, 9th step, 40 divided by 8 gives us 5. Then we look at 8 multiplied by this 5, which gives 40. So subtracting 40 below just leaves us with 0. So we have now completed the division sum we wrote out of 17 divided by 8. And the result we have is the answer, the decimal form of our initial fraction 17 over 8, which is 2.125. So we've changed 17 over 8 to its decimal form. Now for example C, where we look to change the fraction 8 over 3, we've already wrote down the first 4 steps, because this is where it actually starts to get a bit more interesting. So let's proceed with the 5th step, where we bring down the next 0, and we'll see what happens. Gives us 20. So our 5th step, 20 divided by 3, without remainders, is 6. Then our 6th step is 3 multiplied by the 6, 18, which is subtracted below. And 20 minus 18 gives us 2. Now let's bring the next 0 down and see what happens. So we get 20, that's the same as we had before. But let's go through the process anyway. So without remainders, that gives us a 6. And then again it's 3 multiplied by this 6, 18. The subtraction gives us 2. So I think you can probably see a pattern here. Okay, we could keep writing zeros, and we could keep bringing them down, but it's going to keep happening that we're going to have 20 minus 18 each time, and we're going to keep getting 6's on top, on and on and on. That's because 8 over 3 is a repeating decimal when it is converted to decimal form. So, to write 8 over 3 in its decimal form, we can just round to a number of decimal places. Let's just round to 2. But the real decimal form is just going to be 2.66666, going on and on forever. So this is a perfectly reasonable answer. The decimal form of the fraction 8 over 3, 2.67 to 2 decimal places.